purpose of Lab 2 is to use the momentum principle and Newton's second law to describe the motion of a falling object. Some key formulas that I used were the equations for Newton's second law and that the net force is equal to the weight force minus the drag force. My results found that the model using the drag force was much more accurate than the model that did not use the drag force. I took a video of a jar of peanut butter falling after it was at rest. The system includes the jar and the gravitational and drag forces acting on it. I used the diameter of the peanut butter jar to calibrate the video and set the origin to where the jar is at rest and said that it moves in the negative y direction. After showing the video, it is clear that the object is speeding up because the dots in the video that show the center of mass are getting farther and farther apart from each other. I then chose to make two models in Python, one not accounting for the drag force and another one including the drag force. The first one, without the drag force, has the initial velocity equal to 0, the initial position equal to 0, and the mass of the object equal to 0.45 kilograms. This model is solely dependent on gravity because the drag force constant is equal to 0. After running this model, you can see that the only arrow that shows the force is one pointing down, that is the weight force. This model is somewhat accurate, but can be improved by adding the drag force. I can do this by setting the drag force constant equal to 0.8 and setting the net force equal to the weight plus the drag force. This model shows that there is a force opposing the weight force, which is the drag force. I then graphed these models in a spreadsheet and showed the difference in the model without drag force and the model with drag force. You can see that the model with the drag force is very accurate and very close to the experimental position. Some discrepancies from this model include that the axis was tilted in the video and tracker and that the camera moved slightly during the process of filming. This would cause the jar to not fall perfectly along the y-axis and skew the results of the position. So what does it mean? The model that does not include the drag force gives an overestimate of the velocity because the curve has a more negative slope. The model that does include drag gives an accurate but slight underestimate of the object's velocity. The model with drag force does predict a terminal velocity when the drag is equal to the weight force. So what if? The terminal velocity of the object would be the same if it were thrown downward as it would be if it were dropped. However, the velocity will increase if this initial velocity is less than the terminal velocity, and but the velocity will decrease if the initial velocity is greater than the terminal velocity. I can show this by creating a model where the initial velocity is -5 in the y direction. After running this model, there is a greater force opposing the weight force, but the final slope of the motion is the same as with an initial velocity of 0. So this experiment yielded that the model that includes the drag force gives a much more realistic depiction of the motion of a falling object.